Dear friends, we finally arrived at the moment we've all been waiting for, the experiment where we put everything we've learned so far into actual code. In this new series, we'll take the concepts from our Explainable AI, XAI, videos and use them to build a small but powerful self-help app. The first version will focus on journaling for self-discovery, shadow work, and emotional availability. Later on, we can expand it into features that also help us assess our own growth and even the dynamics we have with others. Now, let me reassure you, when I first started learning, experienced developers told me not to worry about memorizing every bit of syntax. Instead, focus on connecting your goal with the right tool or library, and that's the mindset I want you to have here. Machine learning, ML, is not about throwing formulas at data, it's about listening to what the data is trying to tell us. That's the heart of XAI. Every object, variable, and attribute has a meaning, and once you see it, coding becomes about critical thinking, not memorization. Each of the videos we've covered so far led to the following blueprint. Our app is meant for self-exploration. Think of it as digital shadow work. You'll be journaling, but we'll structure those reflections in a table so we can later analyze them. You can download a ready-made template in the video description. This table combines insights from Bowlby and Ainsworth's attachment theory, Richard Schwartz's internal family systems, Jungian archetypes, and Peter Levine's studies on somatic experiencing. Coping strategies relate to the cognitive, behavioral, and schema therapy, while the awareness lesson extracted and the integration status are based on constructivist developmental theories. For demonstration purposes, we've asked our good friend ChatGPT to generate a dummy diary dataset for a fictional person in their 30s with the most frequently met psychological patterns. Before you go along, please download the table, make yourself comfortable, and start reflecting on your own victories and ongoing battles. The data I am working with reveals the inner world of this fictional person created by ChatGPT, so please focus on the data exploration strategy and not on the results. The first step is to import the appropriate libraries. Because we'll work with datasets, we import pandas, shortened as PD for convenience. And since we'll be building ML models, we also bring in scikit-learn, sklearn. That's enough to get us moving. Let's have our columns at hand first. Since we'll be working with a dataset, we should get our features accurately. Having our columns at hand will be of great help, you'll see. I'd like to separate some key columns which include lesson awareness extracted, action, integration, step, reframe, higher self perspective, healing method employed, emotional release, completed, integration status. These act like tracking columns. They remind us that once we uncover a shadow, the next step is to process and integrate it. Seeing that progress can actually feel uplifting, like proof that healing is real. We'll get back to them in our further videos. Now let's do some data cleaning and feature selection. As you journal, you may find that some events no longer affect you the way they once did. That's a sign of growth, and in ML terms, it's where data cleaning comes in. We start by finding single value or low variance columns, things that don't change much and add little insight. In pandas, we can do this with the .unique function. Columns with fewer than 3 unique values are usually not very informative. We'll use a list comprehension to identify and filter those out. Then, let's look at outliers. Which reflections mattered most? A quick rule: anything with a significance score above 8 is critical, and if those are still marked as raw in your integration status, they're urgent. Now comes the question: which of these entries impact our inner world the most? Two main tools help us here. The first is correlation, which shows how features move together. For example, you might notice a strong link between a certain wound and the coping strategy you use. That's the kind of insight that makes journaling data powerful. However, our journaling table is mainly based on text data, whereas machine learning models only recognize numeric inputs. So what do we do in this case? The one-hot encoding transforms text data in numbers so that our model can properly work with it for correlation. Then we calculate the correlation matrix and then filter out the strongest ones. We're especially interested in strong correlations, above 0.7, but we avoid perfect 1.0 correlations, often just duplicates of the same data. Your strategy is to go through every value in the dataset, which we can cover by iterating through columns and indexes. To avoid self-correlation, the index column must be standalone, while the values which may be extracted should go as absolute value. We'll append our blank list with tuples of the index, column, and value. We are not done yet. Since correlation between A and B is equal to the correlation between B and A, we have to drop duplicates. Our goal in creating this function is to get the features with strong correlation. We'll therefore use our strong list to create a dataset with two features and another third column with the correlation value between them. To avoid duplicates, one of our feature columns must lower than the other. We'll return our dataset sorted by correlation. Now let's see what we got by calling our function on the correlation matrix. first thing we have to do is see which of the columns don't actually represent features, disturbing our results. The first one is the data of reflection column. We'll get rid of it by creating a new data set without it. We'll call that undated. In the fictional profile created by ChatGPT, we see these three episodes. Correlation highlights causes and effects in our responses, allowing us to identify wounds which activated some patterns, such as our triggers, fears, or even our attachment style. Connecting to the coping mechanisms we subconsciously put in charge, correlation becomes essential to our healing strategy. Now let's go for our second feature selection tool, mutual information, which reveals hidden dependencies. Mutual information demands that values not only have to be numerical, but also integer. Therefore, for mutual information, we are going to use label encoding. We start by importing the label encoder function. Let's create a copy of our dataset which we shall further use for encoding. Since our dataset includes data of various types, we're going to uniforms them as objects. Now we're going to apply the label encoder function on each column. For mutual information, we have to import the mutual_info_classif from the sklern.featureSelection library. Here, we treat the scale of significance as our dependent variable y. All other columns become features, x. Using mutual_info_classif from Sklern, we calculate how much knowing one feature reduces uncertainty about y. We go for discrete features equals true because we want categorical and not continuous values in our results. Mutual information reveals hidden dependencies we are not aware of, like how a somatic reaction to a boundary violation ties to a specific wound. When interpreting data based of mutual information, features with a value of above 0.5 stand out as strong predictors. Those between 0.2 and 0.5 can be regarded as moderate, while those below 0.1 weak. So today, we've set up our journaling data set, cleaned out low variance columns, identified urgent outliers, used correlation and mutual information to see what really drives our inner world. In the next video, we'll go one step further and start testing models. That's when the patterns you've been journaling will start to translate into predictions.